Dialysis treatment for individuals with chronic kidney disease relies on the diffusion of solutes through a semi-permeable membrane. In this experiment, we'll use a laboratory dialysis membrane to illustrate the selective permeability of the plasma membrane. This video will introduce you to dialysis tubing, define diffusion and osmosis, explore some variables that affect the rate of diffusion, and allow you to predict the result of one of the dialysis combinations you'll be performing in the lab. The dialysis membrane we'll use in this activity is manufactured as dialysis tubing and will be configured into dialysis sacs. Dialysis tubing has microscopic pores that allow water and some solutes to move through the membrane from the inside of the sac to the solution outside, and vice versa. This movement is similar to the movement of water and solutes through a selectively permeable living membrane, the plasma membrane. Two passive processes used for the movement of solutes or solvents through a membrane are diffusion and osmosis. Diffusion is the movement of solutes from a region of their higher concentration to a region of their lower concentration. The diffusion of molecules in general explains how you can smell food cooking in the kitchen when you're in a different room. The odorant molecules from the food are in motion, and they collide with each other to result in the molecules evenly dispersing, or equilibrium. Diffusion is the movement of the solutes from an area of higher concentration of solutes to an area of lower concentration of solutes. Osmosis is the movement of a solvent, such as water, from a higher concentration of water to a lower concentration of water through a semi-permeable membrane. So osmosis is just a special type of diffusion, where a solvent, rather than a solute, is moving. The movement during diffusion and osmosis is from high concentration to low concentration. In other words, down or along the concentration gradient. While diffusion moves solute molecules, osmosis moves solvent molecules. Let's check your understanding. Are both diffusion and osmosis passive processes? Yes or no? Diffusion and osmosis are both passive processes. However, osmosis is the movement of solvents, not solutes. In the lab, you'll prepare several dialysis sacs and the corresponding beakers of solution in which the dialysis sacs will be submerged. Let's look at sac number 1 first. In this sac, you'll have a 40% glucose solution. In the beaker, you'll have distilled water. Let's check your understanding. If the water is moving initially down or along its concentration gradient, from high concentration of water to low concentration, in which direction will water move? Into the dialysis sac, out of the dialysis sac, or both into and out of the dialysis sac? The movement of water into the dialysis sac will be down its concentration gradient because the concentration of the water is greater outside of the sac. The rate of diffusion depends upon a number of factors, including the size of the molecule, with smaller molecules moving faster than larger molecules. The pore size of the dialysis tubing can vary, but usually it's permeable to glucose, ions, and water, but impermeable to larger molecules such as proteins. Let's check your understanding. Assuming that both water, with a molecular weight of 18 grams per mole, and glucose, whose molecular weight is 180 grams per mole, can move through the membrane, which of the following is true? Glucose will move faster through the membrane, water will move faster through the membrane, or both molecules will move at the same rate. Because smaller molecules move faster than larger molecules, water will move faster. In this experiment, you'll observe diffusion and osmosis with dialysis sacs submerged in beakers. You'll record initial and final weights of the sacs to determine weight change, and test for the presence of glucose and chloride in the beaker and sac fluid. Let's go back and revisit sac 1 one more time. Sac 1 contains 40% glucose and will be submerged in distilled water. Based on your knowledge of diffusion and osmosis, what will happen to the sac 1 beaker 1 combination at the end of the experiment? As you head into the lab, consider what your prediction would be.